company called Riffyn. We're actually very close by, about 3 blocks from here in downtown Oakland. So I'm kind of glad to be sharing this lovely Oakland lake-based weather with you all. I'm going to be talking about the application that I've been helping to build over the last 2 years. It's designed principally for people in research and development laboratories, and it's focused on the design and improvement of experimental processes. Is there anybody in the audience who's in an R&D lab? Yeah, great. So there's a couple of people that might have a clue about what I'm talking about. Everybody else just enjoy the pictures. Right. So I'm going to start with a little history. Here are Tim and Tom. They are effectively the founders of Riffyn. And in the beginning, there was yeast. They met at a company called Amaris, which is also nearby up in Emeryville. And their job there was to scale up biofuel production. So what you see in this photo are a series of vats. And the idea was to take what they were doing relatively successfully on the lab bench and scale it up so that it would work just as well in the vats. And that turned out to be quite a challenge. So after struggling with a variety of approaches, they ended up taking inspiration from something known as Six Sigma, which is, as you can see from this kind of talisman type thing on the right, very management consultant friendly. But the story of Six Sigma is that in the 70s and the 80s, the car industry in Japan was trying to find out ways to improve the quality of their production line. And what they resolved in this particular approach was that by exerting more careful control over all the different sources of variability in their production line, they'd get much more reliable results. So this was really the notion that Tim and Tom took to heart. So in theory, we've got a lot of different things we might want to vary, or maybe could just vary by themselves as we're conducting a process. And what we're trying to do here really is to reduce error by figuring out where that error resides, how the variability comes into things. We can ultimately make the yield more reliable. And what that then potentially means is that we can do certain kinds of longitudinal analysis that were maybe harder before, because our data was maybe a little bit too variable, a little bit too ad hoc. By pulling it into a consistent structure, we also have this ability to start doing certain kinds of joined data analysis that might have been harder otherwise. So ultimately what we're saying is that by improving quality, we'll get more predictable results at scale. So that's the sort of backdrop. Now, the Riffyn remix of this Six Sigma, and I promise after this slide all of the sort of management consultancy preamble will yield to something a little bit more based in reality. But in essence, what we're saying is that you start by designing a process. Now, as I'll come on to in a minute, there are a number of conventions out there for designing and sharing processes, but they aren't necessarily as structured as you might need if you want to then connect experimental data across your steps of your process in your measure phase, and then ultimately find sources of error via analytical techniques. So this virtuous circle is intended very much to be an iterative approach. Over time, it's going to be possible, once you start identifying these errors, to control for them in different ways, to lock down certain kinds of previous sources of variability. And the idea is to ultimately make your process the kind of process that can happily run cars on ethanol or whatever. So I promised I would talk about visual tools, and I just thought I'd say why we decided that we would make what we're doing a visual tool. So on the left here, we see the quitclaim deed associated with a particular property in Massachusetts. Now, what you'll gather, it might be a bit hard to read, but it's a very arcane form of legalese. And what it's trying to do in its very painstaking stepwise fashion is describe the same shape that can be described with this diagram on the right. There's something to be said for schematic representations in terms of the instantaneous way that they can communicate to us the underlying intention. Visual tools also are great for bringing in a rich array of data into a single place and then to make it easier to collaborate with that data. So here we see the journey that my boss might be taking to work, and he can not only plot that on a map with live traffic, but he can also send it to his phone and then maybe also send it to me so that I can have a cup of coffee waiting for him by the time he arrives. Visual tools are also great for modularity. We took a lot of inspiration from CAD software. If you look at the kind of component-based approach that's common in CAD, once you've figured out the sorts of basic forms that you're going to use again and again, you can turn those into a library of components. And over time, you can increasingly work in a higher level way with respect to how you piece together your models. It's kind of like Lego blocks, and that's something that we wanted to do with process design. Finally, visual tools help tell stories, and that's kind of where I come in. In a previous life, I worked in news. On the left, we have something I did at The Guardian some years ago, where people could have a sort of rather playful attempt at setting the UK budget. The outcome was that most people wanted to cut Scotland, solve the deficit. And on the right, we have something I did at the Times, which tried to highlight the potentially misleading tracking of activity that certain fitness trackers might provide in contexts like eating a bag of chips vigorously. Okay, so I'm going to actually look at our software now. The essence of how people will spend a lot of time with our product is in design mode. And that's really in terms of what we're trying to achieve. We're trying to bring a material flow-based approach, well, effectively a flowchart-based approach to something that might historically have been represented in longhand form. So protocols are very common in labs. Rather than bringing up something of that nature, I'm going to bring up this kind of pseudo protocol from the Blue Bottle website. People into fancy coffee will often go to great lengths to produce that coffee, and this Chemex recipe goes to show that you can make a very beautiful presentation of a protocol. You can isolate every step, the fact that the grind of the coffee should be coarse like sea salt. You can give people this kind of luxurious sense of what the ritual might be involved. But what you're not doing, if you take this approach, is giving people a model that captures that actual structure of how the resources connect between the steps. So what you're often going to struggle with if you have a protocol like this is once you start gathering data, how to make all that data connect together. So the idea of making coffee is going to be central to the example I'm going to show you. And as you can see there, the endpoint is this delicious artisanal experience. So what I'll do is I'll jump right into one that I made earlier. You'll see on the right-hand side we have a version history. This is actually maybe not quite as involved as using GitHub or something like that, but it's very handy when it comes to auditing and being able to give people a sense of how their process evolved, particularly in a collaborative context. And you can go back to any version. So what you're then seeing as I start to go through the series of steps that I've defined here is that each one of those steps can have its own sort of subset of procedural steps. So on the right-hand side there, you're seeing all the same kind of content that was in that Chemex recipe restructured in this, this flowchart. So boiling water and measuring coffee, start off independently. We then have these sort of points where the water that's coming in from the right-hand side is sort of forked between two steps, and then a lot of other things kind of combine back together at the point where we want to brew. So to actually look in more detail at how we would put that together, I'm going to start playing here a little video of how the editor works. So once we've given our process a name and a description, we can enter the design canvas, and we can sort of, in this particular case, look at how creating coffee for the team at work could be improved by attention to the things that can go wrong with it. So you'll start with just a single step on the canvas. You can edit that, and via a pretty simple mouse-driven interface, you can then actually build things up in what I would imagine is a fairly intuitive way. There's an ontology behind this dynamic search here, so you can customize that ontology, but ultimately, as you build this design, you're using standard ingredients that will mean that it will be compatible with other designs that you might produce in your organization in the future. And you'll see here that the resources are both inputs on the left and outputs on the right. And each one of those resources can be defined in a lot of detail, and I'll come on to that in a second. So you get the idea with this. What's also nice is there's a fair amount of control with respect to how you connect up the resources and the steps. So the actual layout that's being used is a sort of automatic layout of a directed acyclical graph, which is not dissimilar to some of the stuff that Thomas was just showing. But in the main, the idea is to avoid spending too much time worrying about how to make that layout. If you were trying to do this sort of thing in Visio, you could end up going down all sorts of rabbit holes with that. So what I'll just quickly show now is once we've added steps, in this case we're going to add this sort of pivotal moment where we brew the coffee. We will automatically carry over the sort of first resource there, which is the filter paper, but we can then drag in all of the other resources that are required for brewing. So there's the water, and here's the coffee, and what you'll see, I think, once that comes in is that it automatically adjusts the layout to whatever it thinks might be best. So one thing that misses is that as you're building this kind of flow, you might have some kind of state change going on in your resources. So in this case, the brewing coffee step is going to take in all of these different things and is going to yield brewed coffee on the other side. Now, when it comes to the kinds of analysis that we might want to do later, it can be very useful to have a kind of genealogical sense of where that brewed coffee came from, what the constituent parts were. So what I'm showing now is how you can basically register all of the things that have gone into that, or a subset of those things, as components. And in fact, there's a number of different tools that we've built in here to enable information to sort of flow across that graph. So once the graph's in place, if you start to add metadata on the left-hand side, you can propagate it downstream and it will be available everywhere, even in the components that reference the inputs. So at the heart of improving a process is experimentation. As I was explaining, the plan is basically that we want to iterate on that process. So in this case, we're making coffee, and we want to see, is that coffee working for people? So in this particular example, we're going to attempt to define a measurable outcome. So I'm going to add two more steps here. The first is the drinking of coffee, which involves a human biological specimen, or a subject, as one of the resources, one of my willing co-workers. And then finally what we're going to do is we're going to actually see how much code they wrote as a result of drinking that coffee. So we're going to have a human subject on the input side and GitHub commits on the output side. And what we're ultimately gearing up for is being able to experiment with all of these different parameters that we've kind of now got an idea of across the experiment. So we better tell the model about what those parameters could be. And we do that in the form of properties. So if we now look back in the version history, we can go to a slightly more enhanced version where a series of properties have been added to all of the resources. So you'll see in the panel on the bottom here, there's quite small text, but there's, for example, a volume for the water. There's a manufacturer for a boiler. There's the origin, whether it's tap water or filtered water or Evian. There's the temperature of the boiled water, and so on and so forth. All the way through our process, every single one of the resources that we've defined can have any number of properties. And I think the kind of useful thing to point out about that is that you can start very simple. We could model this process in a very elementary way to begin with. As we start to experiment, as we start to maybe guess that there might be more to it in terms of finding the optimum yield, we can add more detail in, we can experiment on more facets of the process. So I'm not going to actually look at the data gathering side of our app in any depth, mainly because there's too much of it. There's a whole system for parsing arbitrary data files. We've got APIs that will connect up with a lot of common stuff found in our customers' corporate IT setups. We've got manual data entry via mobile apps. We've really tried to kind of make it unlimited in terms of the number of ways that you can put data into the system. But the key to all of that is that as you add data, you're always connecting it back to this process design that you've made. So rather than your data just being a sort of grab bag of arbitrary Excel files or CSVs or whatever, it's actually all connected back to the semantic sort of metadata that you've built up in the process design. And what that then allows for are some analysis tools. Now, this particular phase of the product is something that we've only really been working on for the last few months, so it's rough around the edges. But there's a particular use case I've been trying to, with my sort of personal interest, I'm kind of focused on this interactive visualization stuff. And the case that I've been trying to solve for is hit picking, which is any situation where a customer might be doing high throughput screening or some kind of process where they're, with each generation, getting a lot of possible candidates, and they're trying to sift through those candidates and choose ones that might be more interesting than the rest for informing how future generations could look. So this is a browser-based tool, and I think the way that I've kind of tried to structure it is that it's suited to quite big data. And by quite big, what I mean is potentially like a couple of million rows. But the thing I've really focused on is that by the time you've connected data across a process, you can really have a very large number of dimensions. So we load the dimensions on demand, and as such, we can deal with situations where you might have hundreds of different dimensions. Now, the filters that we start to apply are, this sort of cross-filter setup is probably pretty well known to you by now, but what's great is when you start working with the wall of data that you saw in that initial scatter plot, and you start to find maybe that the medium ground coffee somehow starts to yield better results than the others, you can leave that filter dialed in to remove the fine ground coffee from your results. And you can stick something else onto the color scale there. And if you forgive the cognitive dissonance of the mug colors and the actual colors that have been chosen for the palette, we find out that red mugs help people to get the most of their sort of coffee drinking experience. So we'll keep that locked in. And we're going to proceed on to a continuous dimension here in the form of the water temperature. And across this distribution, we start to see that people don't like lukewarm water. So we're going to filter out everything that's beneath, say, 70 degrees. So on and so forth. The main problem with what we've been looking at so far is that subject weight is this sort of fairly uniform distribution. If we switch the x-axis to one of these other things that we have available, we can actually start to see some quite pronounced stuff. So the water volume is ultimately going to control for the dilution of the coffee, and the sweet spot seems to be at about 700 milliliters. If we go lower than that, we're making the coffee too strong and people are sort of jittering wrecks or something. So we can, having kind of captured that in our filters, change this again. And perhaps finally what we'll do is we'll look at the coffee mass. So again, we sort of see, just by showing all the data in this way, that some kind of pattern is present. There's maybe a sort of sweet spot towards 50 or 60 grams of coffee. After that point, again, the coffee's getting too strong. And what we're doing here is we're increasing that sort of tightness of the filter on the lines of code produced. As we sort of zoom that in more and more, we start to get from what was initially hundreds of thousands of data points down to a manageable enough number that we can actually kind of go into the chart and maybe start interacting and looking at the individual items. And what I'm working on right now, so this is something I coded yesterday, so it's a bit kind of, yeah, there we go. You not only can discover data, you can also then share that. So this tries to capture the idea of tagging the interesting candidates. By tagging the candidates, you can then see them whatever view you choose to explore. And ultimately, what I'll be building next is the ability to see how those candidates associate back to the process. So because we know which of the steps in the process, for example, introduced the variation in grind, if we find out that medium grind is the way that people will enjoy their coffee the most or be most productive from the coffee, we can lock that down. We can make that a sort of hardwired part of the next version of the process, and we can focus on something else. So that's the kind of basic idea that I'm trying to convey. There's this sort of virtuous cycle where having that process design really elevates some of the analytical possibilities that are open. Now, the final thing I'll say, we don't want people to try and achieve all of their analytical aims in a browser-based interface. We recognize that everybody's got a lot of tools of their own that they're very happy using. And so we have an authenticated API that can easily be dropped into RStudio or Jupyter, and any kinds of packages that you care to use in those contexts will then be available to you. So yeah, that's it. Improve. Everything gets better over time. Robot overlords, not too far away. I will take questions if you have any.
Thank you for the presentation. One thing that I'm always kind of worried about when I'm seeing kind of these exploratory GUIs where you kind of play towards some kind of revelation is that you kind of lose the process. You get builds up all these insights in your head, but you kind of lose the process of how you got there. Is there any kind of contingency built into the program?
Yeah, so what I didn't really talk much about is how our technology works. So as I was interacting with the application there, everything that I did was actually being fed through, because we have a sort of a system that uses representational state transforms. So it's a bit like Google Docs or Google Sheets. So you're connected via your browser. If I was connected to the same analytics worksheet as you, I would actually see all the stuff that you're doing. But furthermore, we can choose to build a history of that. So kind of like a transactional history. So, ultimately, there are use cases we have with some of the life sciences companies we work for where they need to audit everything. But I mean, maybe they wouldn't be as painstaking as wanting to know every single step that they made. But nonetheless, we could do that kind of journaling if people wanted it.
And I'm obviously a coder. Can you replay that on new data?
Why not? Yeah. All right, thanks for listening.